So has anybody been on the New River Gorge catwalk tour? You ever been on that? When I was in undergrad, one of my friends, one of the students, went to the professor and said, "You lied to me." Looking down at the supports on the ground, said, "I don't see a triangle or a circle. You lied to me." There's my joke. All right, let's get. Oh. That was like a 2.
Is this a blue background? Or is
Yeah.
Oh, man, you're messing with us.
Yeah, because I got the exam one.
Oh, my God. I can't do this.
That's probably a little bit OCD because I was matching the syllabus and whatnot. All right. Exam on Friday. We start at 9:55 a.m. and hold on. What's that? 9:55.
Oh, that's better.
We'll start at 5 a.m. if you want. No. I asked this last time, and I wanted to be clear. Does anybody have class at 11? No, we press on in there. No. Does anybody have class at 11? Okay, all right. Then we will go to 11:30. No, I'm not making the exam any longer, but I don't want it to be a time cruncher, so I'm giving you more time. All right. Does that sound good?
Listen, he called time and over half of the class was still there. Still working. Over half of the class.
You should have, hey, Dr. Michael stood there for Dr. Ford's exam last year with no one.
Y'all are just letting the pressure get to you. That's all I'm saying. Is he trying to take my jokes and like consolidate them into, consolidate? Okay, somebody got it. Yeah. 1, 2, 3, 4, 5, 6, 7. Didn't resonate well with 5. I could start talking about flow nets and say his jokes have equal potential as well.
Please don't. Please don't. Flow nets are my bad.
I totally understood what needed to happen on a flow net, and I could just not. I was never that good at it. All right. All right. Let's settle down. All right. So here, let's talk a little bit about the exams. Everybody's aware of the format. Everybody's aware of what's going on. All right. So first off, closed book, closed notes. You got a calculator or formula sheet, 8.5 by 11, front and back. Just put anything you want except for worked out examples. Okay. We're going to start at 9:55 a.m. You'll have scratch paper, you'll have a stapler, and I will also provide any tabular data that you need. So you don't need to be worried about rebar sizes or anything like that. And if there are any necessary figures from the beam design aid, I will provide that as well. So you don't need to worry about that. Okay. I'm not saying. Well, let me say this. I'm not saying that WL squared over 8 is probably not something you should have in the back of your head. But if there's any esoteric beam analysis guides, I'll provide those. Okay. Sound good? All right. Let's talk about the topic. So number 1, fundamental. Yes, sir. If you need those, I'll provide them. Yeah. You don't need to worry about that. I'm not going to A, make you memorize them, or B, I'm not going to reduce the amount of room you have on a formula sheet for those. So if you need any of that, you'll have it. Okay. Make sure you know the process, structural engineering, the bidding process, all that. We talked about that. Make sure you know the differences between ASD and LRFD. Make sure you can identify tributary area of given elements. And you can do basic load takedowns for gravity loads. So if you need to, make sure you can do lab load reduction, and obviously make sure you can factor loads. Also, I'm not going to get crazy into detail, but make sure you just have a general understanding of the lateral stuff. Make sure you understand fundamental properties of concrete. By now, if you don't know what FC prime is, something's wrong. So make sure you understand what a stress strain curve for concrete looks like. I'm not going to ask you to start drawing each individual point, but you need to understand the basics. All right, for flexural analysis and design, make sure that you can analyze beams that behave elastically up until their cracking moment. So you need to understand cracking moment. Make sure you can analyze after they've cracked. So that means transform sections. You know, the modular ratio, the N value. Make sure you can do that. Make sure you can do the stress block, 0.85 FC prime to get your nominal moment capacity and phi times your nominal moment capacity. So make sure you can also verify ACI requirements for steel area and the steel strain. Be able to design a beam with an open cross-section, a beam with an open cross-section, and a slab. Okay. Now, as for everything else, I've given you some stuff on the loads. I've given you live load reduction, all the parameters associated with that you need. You've got the load combos there. I've given you material properties as well as modulus of elasticity formulas. I've given you the lambda values for normal weight concrete, lightweight concrete, and sand. Let's see, you've got the E for steel, which that should be burned into the back of your memory right by now. You got F sub R, your modulus of rupture, your modular ratio. You've got your cracking moment, which is FRIG over YT. You all should have the parallel axis theorem memorized by now to get your moment of inertia. But the big ones on the right, we've got A, our stress block depth, which is equal to beta 1 times C, but it's also equal to ASFY over 0.85 FC prime B. So using those, you can do your, or compute your nominal moment, ASFY D minus A over 2, and then the strain in your steel. I've also given you this, which has all your notation, so you know what B is, you know what A is, you know what C is, etc. You've got the relationship for beta. What's up?
So you've given us that?
I've given you this review. It's not going to be on the exam. No. I have given you the relationship for beta 1. This would not be on the tabular guide. You'd need to write this one out. And I've also given you your relationship for phi. Okay? So in this little packet is everything. Okay? It's literally all there. So the only thing left is row values for design. We spent the majority of class for an unknown cross-section using this one. You can use this one as well. I'll go ahead and tell you, I'm not going to put that one on the exam, but I want you to just be aware, bless you, that you can design just using a blanket value of 0.18 FC prime over FY, or you can design to try and achieve some target strain in your steel. So if I want a strain of 0.009 in the steel, I can plug in 0.009 here, plug and chug, and figure out what my reinforcement needs to be. There's really not much to it. It's pretty simple. These two row values right here are for unknown cross sections where you don't have a clue what the beam looks like. However, if you do know what the beam looks like, you plug and chug and solve for a row. Okay, and that's the same thing for a slab as well. Speaking of slabs, we have our area of steel required for main steel is rho BD, but for temperature steel it's 0.0018 BH. Okay. Lastly, your two ACI requirements, make sure your strain's bigger than 0.004 and your minimum steel requirement has been met. Sound good? Okay. Now a couple things before I open it up to questions. Number one, I have homework 4 graded, so I'm going to pass that out here in a second, but I'm also going to give you out the solution. All in all, for the most part, everybody did pretty well. So I'll be honest, I really don't think there's a lot to say. I looked over them this morning, and they were all pretty good. So 2, 3.
So one-way slabs was the last thing.
Yes. All right. Okay. So what I'm going to do now is kind of shut up on the lecture and let you all ask whatever you want. While you all are asking questions, I'm going to be handing back your homework 4. Everything's posted on Blackboard as well, so I've got all that. But if you got questions, go ahead and start firing them off. Yes, sir. It's the same format as all my others. One set of conceptual questions and then 3 calculation-based problems. Same as I always do.
Are you going to want to obviously choose the most economical or choose the bar size?
When in doubt, yes. Yes. Now let me say this. The problems on this exam are designed, no pun intended, to reduce the amount of iteration necessary. In other words, you do them correctly, you shouldn't be iterating 86 times to get the final answer. It's questionable, not more than once. I will say not more than once, yes. When can you tell whether or not the steel is in the top or the bottom? Are you talking about like the difference between a cantilevered beam and a...
I guess I just didn't know why the steel was in the top.
Well, because all right, here's a... Hold on, look. Here's the cantilevered beam, right? And I bend it, the top's being pulled apart. Top's in tension. Like that's it, really.
Are you going to tell us whether the loads need to be reduced?
Right. Question was, am I going to tell you whether or not the loads need to be reduced? You will know one way or the other. I'm not going to tell you how, but you'll know one way or the other.
The bulk of this is going to be on design, like analyzing your reinforced concrete beam and be on the snow loads and
Yeah, I mean, homework 1 to homework 4. So
homework 1, 2, 4.
1 through 4. 1, 2, 3, 4. And any others? I mean, everybody's kind of quiet. Well, not really quiet. But. Yes. Yeah. You can't reduce, like, let's put it like this. You can't take 100 PSF and reduce it to 15. Like, there is a reasonable expectation that you're not going to see all that live load. That being said, the code and just really common sense won't let you go below a certain value. So if you've got a floor beam, it's 50%. But if you're talking about a column, essentially an interior column in a building, 40%. Does that make sense? Anybody else? This is good stuff. Yeah.
So, because technically it may not be the most economical because you could have fewer bars or something else.
True, but in order for us to scientifically get into that, so the question was, what do we do in terms of fewer number of bars versus steel area? Okay, here, first off, on the exam, the be-all end-all final answer is the smallest number of area, or the smallest area, okay? But let's be clear, in order to really answer that question, I mean in real life, we would need to know some larger specifics in order to get scientific about it. We haven't had word one discussion about what the labor rate would be, what the efficiency of a given construction crew would be, availability and shipping requirements. I mean, it's a loaded question. That's why for us in here, we say, when in doubt, minimum, smallest area governs. Now, if you've got 2 answers that have literally the same area, then the answer becomes, well, which one am I going to use? Use the one with the fewest number of bars. Because if it's the same area, it's the same tonnage, but it's fewer pieces to handle. Does that make sense? In other words, if I could get by with using a single number 11 bar versus using 9 number 3s, I'm going to use a single number 11 because that's just a lot less to deal with.
I think I already know the answer to this, but if for some reason we would, because I mean, I use the number 11s, 4 number 11s. If we would use the wrong bar size, but carry out all the rest of the steps correctly, like the trial beam design.
Yeah, no, okay, but let me say this. You all have had me before. You know I'm not going to. Minus 40. Yeah, but I'm talking about my grading policy. I think my grading policy is pretty fair. You've had me enough that
the answer to it, but
you've had me enough that you know I'm not going to be that guy.
right. I just know this homework gonna kick my ass. I'll probably choose the wrong bar size. Will this be similar to the steel exam in that the bulk will be in the designing, well, not designing, analyzing the reinforced concrete beam? That'll be like half the exam, and then a little bit will be on slabs, I guess, and a little bit will be on.
That is a fair conclusion. I'm not going to get into specifics as to this is what's going to be on problem 1, this is what's going to be on problem 2, this is what's going to be on problem 3. I get what you're asking. It's a fair conclusion. I'm not going to get into specifics, but for the most part, you're on the right track. This is reinforced concrete design, so I'm not going to have this massive question on snow. I might ask you about snow, but it's not going to be half the test, you know. So is that a fair answer? No. Well, yeah, it's steel design. It's possible. I mean, let me say this, the thing about analysis problems on exams versus design problems on the exams is everybody should get the same answer. See what I mean? That's one of the reasons why I did that on the steel design exam was everybody doing the work correctly should have all arrived at 101.8 kips. See what I mean? I'm not saying there won't be any design problems on this exam, but that's why that was the case in steel. And honestly, that one problem for that particular topic encapsulated quite a bit. And the fact that it was worth a lot actually worked more in your favor than it did against you. You know what I mean? Because the class as a whole did very well on that problem. So the fact that there was a lot of weight put on it worked in your, I mean, it helped the averages, not hurt it. I don't think you've got much to complain about. For unknown cross sections, yeah.
We calculate row and get all of their dimensions. We only have to recalculate our MU and then our PMN. We don't
Yes.
have to go back and calculate row.
Exactly right. Rho is solely used to help us figure out a reinforcement pattern. Once we get that reinforcement pattern, we don't need it again.
But we don't have to necessarily, if something doesn't work out with our steel, we don't have to change the amount of steel that's in it. We could change the shape of our cross.
You could,
right?
yes. But again, I'm not going to try and create this circular nightmare loop where you have a beam that doesn't work and then you iterate it and it doesn't work again. It stops becoming an examination of whether or not you understand concrete design, and it becomes an exercise in number crunching and writing numbers down on your paper. It stops becoming concrete design. I haven't done that before. I'm not going to start now. Yes.
You're giving
And then
us
you.
a sheet with the bar design and everything, right? We're not worried about
I'll give you all that, the supplemental info that you need. I will give it to you. I won't. Here's another thing I won't. I won't flood you with a bunch of crap and then make you have to sift through it too. You do not. Here's what you don't need to worry about. Okay. You don't need to worry about rebar sizes, beam design charts, slab design charts, or the formulas in that analysis guide I gave you. Now, with that, let me also say it probably wouldn't be the worst idea in the world to just remember WL squared over 8. I'm not saying it'll show up on the exam, but goodness, we have used it so many times that if you don't remember WL squared over 8 by now, you know, we use it like every day we're in here. So, but any of those, like, if I put something on the exam like a triangular load, I'd put the formula there and the figure there. I'm not going to make you memorize that. But one final point, and then I'll get to your question. There's always structural analysis. And there's always drawing a shear diagram and drawing a moment diagram. When in doubt, revert back to what you know. Yes, sir. What? No. They're going to be evenly spaced. So, and the only thing that you need to, look, the only thing that matters in that regard is that you're not picking a rebar pattern that doesn't fit. Yeah, like, you can't put 24 number 3s in a beam that's only 8 inches wide. You know what I mean? But once you have figured out a rebar pattern that fits inside your beam, they're just going to space it evenly. It doesn't matter from an analysis standpoint. It doesn't matter from a design standpoint. And honestly, really doesn't even matter from a detailing standpoint, because when they cast the beam, they're just going to space them evenly, and that's it. So.
How far should we carry decimals by steps so as to not mess up the final answer?
It depends on the step. It does depend on the step, but let me also say this. I do a fair amount of work with the particular problems on the exam to try and avoid rounding issues. In other words, when you look at some of the beam design problems, like you'll see this way that the problems are formatted. If you go through and do the math, like it's hard for that to give you a problem, like it would be on the like on the homework.
On the homework for my slab, I said the space of temperature steel. I should have used number 5 to 12 inches, but I had a suggestion to use number 10. But I guess where our graph is different, we don't have to do that.
That won't be a problem. I can just tell you it won't be a problem. I can't tell you any more than that, but that won't be a problem.
We have to design our beams with another cross section. We have to iterate. Can you go over the some of the things we can do to increase the capacity of the?
Okay. So if you have to iterate, okay, you have a few options. Okay, you really have 3 options in general. Number 1, increase the steel area. So for iteration, pick the next highest steel choice. You know what I mean? That's option 1. Option number 2, change the dimensions. When in doubt, don't change the beam width. Change the beam depth. You will get a higher increase in nominal moment capacity. Guaranteed. Okay? Be clear, if you increase the depth, you will have to update your MU. So my first piece of advice would be change your steel. And by changing your steel, just pick the next one up. Okay? Third option would be to change the material properties. But I'm going to tell you right now, you would be surprised how little that matters. Like you could take your FC prime and double it, and it would not double your nominal moment capacity. It might increase it by a few percent. You'd be surprised how little it affects it. I couldn't hear what you just said. I'm sorry. No. Again, and again, I'm trying to be like absolutely clear on this. My goal is not to make you iterate. Like that's not my goal, because iteration. let me explain what iteration is. Iteration is doing what you just did all over again. I want to test you on doing it. I don't want to test you on doing it again, you know. So, like, everybody's getting a little worried about iteration, and I think it honestly should be the last thing that you're worried about, to be perfectly honest. Concrete design. What? No what? Oh, well, it's the truth. In all seriousness, it's the truth. I mean, if you, look, guys, if you understand homework 1, homework 2, homework 3, and homework 4, you should be fine. Now, come on.
You mean everything we've done in class so far?
I tell you what I'll do. All right, exam 2 will be on homeworks 1 through 7, and then exam 3 will be on homeworks 1 through 9. We'll just make them comprehensive. And homework 3 was short. Homework 3 was really short. I mean, you actually did what you on what you did on homework 3. You repeated it on homework 4. I'd argue that homework 3 doesn't really have much independent material on it because everything you did on that homework, you did it on 4. You know. Blue. I like blue. About that. Well, here's the thing. Next thing you know, if I allow that, you're literally going to come in class and say, so my dog did eat my homework.
You don't understand. She would. She's a piece of shit. She will eat anything. She ate half of a water bottle. She's been shitting out plastic shards.
Okay, all right. All right. I'm going to have to rule against you on that motion. Hey, it's a free world, you know. But there are consequences. All right. Let's get back to the wonderful world of CE 413. Come on. Hey, come on. All right. Any concrete related questions?
So the point of analyzing the cracking moment is to determine if we need reinforcement?
No. Okay, that's a good question. Is the point of determining the cracking moment to determine whether or not we need reinforcement? The answer is no. The cracking, first off, let's be clear. Concrete beams, they're going to crack. There's nothing you can do to avoid that. Go to the parking garage. There are cracked beams, guaranteed. All right. Here's the point of determining the cracking moment, and I don't want to go too far into down the rabbit's hole for later. But later we will use the cracking moment to determine what's called an effective moment of inertia, and the effective moment of inertia, for lack of a better explanation, is used for deflections. Okay, so to delve into it a little bit, when you apply load to a beam, let's say you've got a simply supported beam. So you've got a moment diagram that looks like this, right? So near the ends of the beam, very low moment. Near the center of the beam, very high moment. Make sense? So if the cracking moment, like let's say here's your moment diagram, and the cracking moment is like right here, some of the beam's going to be cracked, some of it isn't, right? So the uncracked beam is going to have a moment of inertia, and then the cracked beam is going to have a moment of inertia. The effective moment of inertia is sort of a weighted average, and then that's what you use to compute deflections. But in order to do that, you need to know the cracking moment. So let me be absolutely clear. There is really no instance that you would have a beam in a building and say, well, the moments are really, really low. I'm not putting any rebar in it. No. You're going to put rebar in it anyways. But that's why specifically it will come up later. Is that a fair answer? Yes. There might be a moment of inertia that, let me say, I'm not going to give you a parallel axis theorem problem where you have 8 different simple shapes. At the very worst, it will be a T-beam. You do need to know the moment of inertia of a rectangle, I'll tell you that, and you do need to know how to compute the moment of inertia of a composite shape. But I'm not going to give you a concrete beam that has a cross-section that has like circles and triangles and it looks like Mickey Mouse or something. I'm not doing that. So, I'm being serious. Like, I won't do. Yes. Well, no, you and you.
Before concrete down like the third floor of the building, most of the time that's gonna be on like a metal deck, right? Or like some kind of metal plate or something,
Oh.
up while it's drying and that kind of stuff.
Okay.
So would that steel have any effect on that concrete tension?
No. No, because it's not internally acting as reinforcement. I mean, it's just literally there to be a form. Like, that's it. So no. That was easy.
Did you say you might give us a T-shaped beam on the exam, but we
Not to compute MN. Not to compute MN or to design them. I'm talking about transformed sections or moments of inertia, which we did do earlier.
Put a lawyer hat on. I got you.
No, look, I will not test you on material that you have not been exposed to in lectures or homework after slabs. I won't do that to you. And, I mean, yeah, again, you're acting like I've done that before. I've never done that before. I've never come in and said, oh, here's a column problem. Come on. Anybody can do anything, man.
Would you get 100 on the
I made it. I know what's on it. I made the solution, so yeah, I probably would.
Is that solution correct?
If the solution, you say, so,
Let me double check your work.
you can make mistakes too.
but I,
Let us double
Yeah,
check.
Dr. White. I'm gonna make a solution. Wait till you sit down for the PE exam, right?
okay,
I bet you'll knock that one out of the park.
I appreciate that.
I'll make the solution at 9:55 on Friday.
You-
Weston said he's gonna make the solution at 9:55.
Oh,
I see what you said.
we'll see.
How do you know if his solution is correct or not if you don't have a key?
I do.
Not saying theoretically. He's saying that his is going to be the solution. How do you know it's DJ Khaled? I apologize.
Well, I don't know what's going on now. We're getting philosophical, and that's like over in the liberal arts department. This is concrete design.
There's steel in it.
Yes, there is.
It's all the same class to me, honestly. Oh, what's going on? Believing together.
Oh,
It's actually kind of stressful.
I know what you mean. I'm breaking my bullshit.
But no, seriously, like, I don't know material. It's kind of scary.
but in some instances, that's a good thing. I mean, it would suck if we used different load combinations in steel and concrete. Like, that would really suck. You know, if it was 1.4 times the dead plus 1.7 times the live in here, but in steel it was 1.2 dead plus 1.6. I mean, can you imagine that? That would suck. Yeah. So. What?
Concrete on your steel.
I'm going to be honest. I don't have any idea what you were saying just now.
It's the Reese's commercial.
Oh, yeah. You have chocolate and peanut butter. You have peanut butter
That's
in
a
my.
callback for you. Way back.
All right. We still got plenty of time, so.
A zebra is white with black stripes.
Oh my god.
Tiger black with orange stripes.
I don't know. I swear I was at the zoo and I realized that zebras in fact white with black stripes.
Can't you go to a zoo?
See, color is a subjective thing.
I-
Because we don't.
I literally don't have a response. You know, I just.
How do we know that we see colors objectively? We just identify them because that's exactly what we're told when we grow up.
That won't be on problem 1 of the exam. I can go ahead and tell you that right now. Yeah, hold on. Did you have a question?
Can we talk about your favorite color, blue? What does blue represent for you?
Maybe that's why we all have different favorite colors. We all really like blue, but it looks different to everybody's eyes. So you see blue as red. But you're like, no, I like red.
Julie's shirt could be blue Stewart.
This guy.
Blue guy. This could be blue me.
I like how I'm the only one with dragons.
Got-
Wavelength is blue. What does blue
So,
represent for you?
so about that rebar, you know, what are we even talking about?
That's a darker color generally.
Maybe.
Th-
I think it's
Is this like something they talk about FYS or something?
I don't know what's happening.
Is this something they talk about FYS? Are you laughing at me or? What did he say?
You said, what if we're all black and you just white?
Okay, I really want to talk about concrete design right now. Yes, it is. I really want to talk about concrete design right now. I just asked on the recording. I said, "Is this something they talk about in FYS or something?"
There goes that teaching.
Yeah, gone. I don't monetize any of my videos. I don't monetize any of my videos.
Yeah, Dr. Ray gets more views on his videos. Does that make you feel inferior?
No.
He has some with like several thousand views. Does he use the HP?
Hey, the FE review sessions I did have a few as well, but I don't care. And all, what's that? I do have more views than Professor Huffman. That is true.
Are you therefore saying that yours are more about the quality rather than the quantity compared to Dr. Ray? Yours are better.
Oh, God. Hold on. I think he has a question about concrete design.
We're calculating both. Are we going to have to do both, like the transform area and the, like, are you going to give us a T beam with rebar in it? Do we have to like transform ends for different sections?
No.
Oh,
No. No, let's get back to concrete because we do have a celebration on Friday, and I want you all to feel comfortable about it. I really do. I mean, all joking aside, no, hold on. All joking aside, I don't want anybody to. Oh God, we didn't know what was going on here. I mean.
Yep.
Now I said come in on Wednesday prepared to ask questions.
We have
No, but in all fairness, that calendar of mine's been there for months. Like y'all know what's going on. But I've had it on the announcement slide like for the past 2 weeks. Like the exam's coming on Friday. Exams. Now I also moved my exam. You know. Hold on. Well, that wasn't a question. Now, I do appreciate the kind words. I would venture to say it won't have much impact on the grading of the exams. It was a nice try. It was a
Can you and Dr. Wright have a bare knuckle fist fight to determine the supremacy of the calculator?
Your wins.
Yeah, HP
My money's on you.
Casio. Are you kidding me? That man has a
They can go for days.
Dr. Michelson's in his 5 seconds.
I'm good. I'm good.
Well, I mean, if you had to compare, he'd be working with water and fluids. Like
He's not a water vendor.
Mike's gonna be knocking him out.
Throw pipes at him.
I mean, Mike's a steel bender.
I do have the samurai sword and/or lightsaber, you know.
I want to see if
If we had an airbender, though.
Dr. Wade
If we had a jet fuel bender, he'd be screwed.
Now I've got the samurai sword or lightsaber.
The lightsaber's not fair. It'll cut right through the pipe he uses.
I know it's not fair, but I have it. All right, all right, all right.
Why do we park in the driveway?
Wow. What are we even talking about anymore? Goodness gracious. Oh my God. I love this job. I do. I'm getting paid to do this. This is awesome, you know.
If we get 100,000 retweets by Friday, we get A's.
But we have to take a picture where we're shaking your hand, something's
It
written
has
on
to be
white.
really Twitter.
What?
We'll write it on the board, and then if we get 100,000 retweets on the picture, we all get A's. By Friday.
Yeah, it's
That's
a lot of retweets.
That's a lot. I got like 400, 500 followers, man. I can't do that. That takes some network.
Not like followers.
I have like none because I don't have a Twitter account.
Okay, well, we'll show you the proof.
Although I don't know whether or not I have a Twitter account. Somebody said they were going to start one, and each one of these little jokes I do, they were going to tweet it out.
Does that count?
For these purposes, I think so. We're adding them all up. Yeah.
What?
So is that a yes?
No, it's not.
Like, when people do that, those 100,000 retweet for whatever, when somebody quotes it and then everybody retweets that, does that count?
I don't think so.
That is meta. That is rather meta.
I'm pretty sure it has to be like all from one.
All right, all right, all right. I am starting to sense that the actual questions on the exam have been somewhat exhausted. Yeah, it took me a while. It took me a while. Seriously though, we do. I mean, is there anything else that you can ask that I can answer on these? I mean, anything. I'm not telling you what the answer to problem 1 is. So, but
What would you give us conceptually that we should look over? And obviously you're not going to say.
That's what problem 1 is. Therefore,
concepts.
Concepts on snow.
No, no. In all seriousness, I would study, I would study the stuff on loads, and I would study some of the behavior stuff early on. And beyond that, I mean, my opinion.
Friction factors or coefficients in the exam, right?
No, but that we spent a lot of time on that one.
Everybody feels it.
What about this?
That's hydraulics. That's hydraulics loops. No, look, that one particular constant in steel design, like we actually did spend a fair amount of time talking about that one value. I know, well, we did. I know we did. But let me say this. We didn't really do that in here. Like we didn't like go all into a particular value. I mean, we just
Drive equations there, so
we did, what's that?
I know you still like drive equations.
But yeah, but when we derived equations, we derived them ultimately just to get that plug and chug design procedure, which is that's what I'm after. And in all honesty, there wasn't a lot of, I'll just say, there wasn't a lot of creativity to it. It was really just 0.85 FC prime, set all this stuff equal and solve. Like it was just alphabet soup. We did use that one day of calculus to try and explain why we used the 0.85 FC prime. That I'm not asking you on. I just wanted you to see it and understand it. I'm not doing that. Do I want you to understand the general ideas behind some of this stuff? Yeah. Final way of answering your question is saying this. I think steel design is a topic that is more contingent on the nitty-gritty details than concrete design. Like there was a lot of things in steel design, like, you know, an 1/8 of an inch is a 1/16 of an inch twice because of this and this, and there's a lot more of that stuff in steel than there is in concrete. In concrete, it really is just sort of, it is what it is. Compression equals tension, some moments. You know, I mean, say what you will, that's really what we've been doing the whole time, just in different fashions. So does that sort of fairly answer your question? Yeah.
We have to do live load reduction. Will anybody be doing it?
Well, there's really only two. Like beams, it's 2. Columns, it's 4. Like so those you can fit on your formula sheet. Yes, that is the response. Anything else? I'm going to challenge you on that one. I don't want anybody to feel like that there's anything that they didn't ask. So is there anything else? In relation to exam 1, is there anything you have to ask? I don't have a, my goodness.
Northwest.
Did you like Cuddy's rock album?
Feel about Lil Uzi Vert. 21 seconds. 22 seconds. So,
Hold on. Hold on. Answer me. Now, I've got a question. Like, when you have review sessions in other classes, like, is this the stuff you ask?
Get review sessions.
We get up and tell them to look over, and Dr. Waite saying have fun.
Like telling me.
But
Yeah.
am I the only professor that you, like,
Where?
Dedicates a day.
no, but the who's your favorite celebrity? I'm just curious.
Dr. Waite, he might. Yeah, I would never even consider
His answer would be Joe Dirt in the middle of class.
Father of geotechnical. I don't still don't know who it is.
Father of geotechnical engineering.
Know how to spell it. K. Yeah.
Eh, come on, it's just gravel, sand, silt, and clay. Come on now.
Yeah. Try telling him. But to him, it's like.
Hey, Clay's just net negative electric charge. Come on now. He was like, yes. All right. Seriously, any other questions at all? Does everybody feel a little better about the exam on Friday? What time? Hold on. What time we're going to be here? 9:55. 9:56. 48. 9:55. All right. All right. We'll see you.